Hello, hello. Welcome back. Okay, in this section, we are going to be covering 4.3 solving absolute value equations and inequalities. Okay, so 4.3, take notes, use the closed captioning button down below, and hopefully you are keeping up with the homework. 4.3. Solving absolute value. Okay, so let's just recall what absolute value is. So absolute value is the distance to zero, basically. Absolute value is the distance to zero. So if I want to know the absolute value of 5, now that is 5 units away from zero. So the absolute value of 5 is 5. And also, if I take the absolute value of -5, well, that is also 5 units away from zero. So that also has an absolute value of 5. Okay? All right, so solving. So when you have an absolute value equation or inequality, you want to start by getting that absolute value by itself. And then you can do the setup. And we're going to look at the 3 different cases where you have absolute value equals a number, absolute value greater than a number, and absolute value less than a number. Okay, and we'll take a look at how you set up each scenario. Okay, so the first case, if you have the absolute value of something, and I'm not going to put our regular x here, I'm going to put this sort of funny looking x here to represent the thing that's inside the absolute value. It could be just an x that's in there, or it could be an expression like 5x plus 2. Okay? Equals some constant. Okay? So we're going to take a look at this scenario. So what happens is once you get the absolute value by itself, so once you get the absolute value by itself, then you would do the setup. And the setup is that x, whatever is inside there, could be just an x, could be a 5x minus 1. That's in there, okay? Equals k. Or absolute value of x, x, this inside the absolute value equals negative k. Okay, so you would set it up like this. Here, when you set it up, you lose your absolute value symbols, and you just have whatever is inside there represented by this funny looking x equals k, or this funny looking x equals negative k. Okay, and then you would just solve each equation. Okay, then solve each. Okay, and I'll do an example right here off to the side. Okay, so suppose that I have absolute value 3x minus 5 minus 2 equals 7. Okay, so again, the first thing you want to do is get the absolute value by itself. So we will go ahead and add 2 to both sides. Let me make this a little longer so it doesn't look like a 13. Okay, so once you have it, the absolute value by itself, then you do the setup. So we're going to go ahead and set 3x minus 5 equal to 9, or 3x minus 5 equals to negative 9. Okay, which makes sense because if this thing here has an absolute value equal to 9, that means this thing in here must be 9 or negative 9, right? Because those are the only two numbers that have a distance of 9 to 0, right? Okay, so once we have our two equations here, we go ahead and solve each one. So in this first one over here, I'm going to add 5 to both sides, and I get 3x equals 14. And then I'm going to divide both sides by 3. So that is one answer. And then I do the same thing over here, solve for x. So add 5 to both sides, and I get 3x equals to negative 9 plus 5 is negative 4. Okay, and divide both sides by 3. So I get negative 4 over 3. Okay. So that's the first case, when you have absolute value equal to a constant, which is what we have here. Now, keep in mind that over here, absolute value is always positive. So if this had said absolute value equals negative 9, well, you don't even have to do any work. You just say no solution, okay? Because absolute value is always positive, as we can see here. Okay. Okay, the second scenario. You have absolute value greater than a constant, okay? So in this case, you would take whatever is inside the absolute value and set it greater than to k. And you would do another one where that absolute value inside is less than negative k. Okay, so if you can try to visualize this, you want the absolute value to be bigger than a number. Okay, so let's say 5. Let's say this were 5. Then you want this to be greater than 5. You want those distances to be greater than 5. So then that would be like the numbers 6, 7, 8, 9, 10. Those all have distances greater than 5. And also negative 6, negative 7, negative 8, negative 9, right? Those all have distances that are greater than 5. Okay, so that's why we have this. So we want these guys to be greater than, let's pretend it's 5. And then we want these guys to be less than negative 5, right? Can you picture that on the number line? Those numbers are getting farther and farther away from 0. Okay, and then again, then you solve each. Okay, so let's go ahead and do an example over here off to the side. Suppose that I have this absolute value, 2x plus 3 minus 1 greater than 5. Okay, so again, we want to get the absolute value isolated by itself. So I'm going to add 1. Okay, so I'm going to cancel this out here by adding 1 to both sides. And that will get me the 2x plus 3 absolute value greater than 6. Okay, now that I have the absolute value by itself, I can do my setup. I have 1 for 2x plus 3 greater than 6. And I'm going to have 1 for negative 6, but I'm going to flip that inequality. 2x plus 3 is less than negative 6. Okay, and then I solve each one. So here I subtract 3. I'm doing this one first, so subtract 3 on both sides. And I get 2x is greater than 3. Divide both sides by 2. X is greater than 3 over 2. Okay, And then solving this one, subtract 3 on both sides. Subtract 3 on both sides, and I get -9. Divide both sides by 2, and I get -9/2. Okay? So far, here, when you have equals, you set inside the absolute value equal to 9 or equal to -9. Okay? And then here, we have this. 2x plus 3 is greater than 6, or 2x plus 3 is less than -6. So we have x is greater than 3 halves, and x is less than -9 halves. So you set one greater than 6, and then you set the other one less than. You have to switch this to -6. Okay? All right, let's do the third scenario where we have less than, the less than case. So we have the equals case, the greater than case, and now the less than case. All right, so if you have absolute value of something is less than k, all right, so absolute value is less than k. Then we have here, we set it up, not absolute value, but this funny looking x is less than k. And here we use the and, not the or, okay? And funny looking x is, we also switch it here. This one is like the original one, okay? This one we switch it greater than negative k. Then you solve each one. Okay? All right, so let's go ahead. Another way to set this up, so an alternate way. So you take whatever you have inside the absolute value, and you can set up this this compound inequality here, where you have negative k on this side and positive k on this side. That's also another way you can set it up when you have the absolute value less than case. All right, so let's take a look at an example. Suppose that I have absolute value 5x minus 1 plus 3 less than 9. Okay, so here we're going to go ahead and get the absolute value by itself. Subtract 3 on both sides, and we get 6. Okay, you have these two ways of setting it up. I'm going to go ahead and choose this one. For some reason, students prefer that one, I think because with absolute value, they're used to setting up two situations. So they kind of want to keep that consistency going instead of introducing this new look here. So I'm going to use that method as well. So 5x minus 1 less than 6. It's like the original problem. And then this is your and. 5x minus 1 greater than -6. Okay. And then we go ahead and solve each one. So starting over here, add 1 to both sides. I get 5x is less than 7. Divide both sides by 5. X is less than 7/5. And over here, add 1 to both sides. 5x is greater than negative 5. Divide both sides by 5. X is greater than negative 1. Okay. So very important. A lot of students will leave out the and the or. Okay, so make sure you write that in your final answers. Okay, because that makes a difference about what we're talking about. Okay. All right. Let's see. Okay, double absolute value. Oh, let me go back to this because we said, what if you have absolute value set equal to negative? Okay, so absolute value equals negative, not going to happen. So there would be no solution, right? If this said negative 9 here, no solution, right? Absolute value is not going to equal negative. Absolute value is always positive. Let's take a look over here. If we had negative 6, absolute value greater than negative 6. Well, again, you don't have to do any work here because absolute value is always greater than negative. So you can say infinitely many solutions. Okay, everything works because when you take the absolute value of whatever it is here, you will always get a positive number and it will always be bigger than negative 6. Okay, so negative on over here, if you have absolute value equal to a negative, no solution. Absolute value greater than negative. Okay, if it said greater than negative 6, that's always going to happen. So your solution is all real numbers, right? Any real number you put in there, the absolute value is going to be bigger than negative 6. Okay, and then let's take a look here. Your absolute value less than a negative number, never going to happen because, again, absolute value is always positive. So if you ever get less than negative, also no solution, just like equals. Okay, not going to happen. Okay, you might have the case where you have two absolute values. So let's take a look at that. Solving double absolute value. Okay, so you might have something like this. Okay, you have something inside here equals to something inside here. Okay, so you still do everything the same. You have two situations, just like the other three. You have this funny looking x equals to positive y. And you also have this situation, absolute value of x equals the negative of this. Okay, and this one here is an or. Okay, so let's take a look. Here's an example. Solve. Absolute value 5x minus 12 equals absolute value 4x minus 16. Okay. All right, so first case, 5x minus 12 equals 4x minus 16. Okay. Second case, 5x minus 12 equals the negative of what you have inside there. Okay. So that's how we set this up. 5x minus 12 equals the positive version of this, 4x minus 16. And 5x minus 12 equals the negative version of that. Okay, and then you just solve each one. So over here, I have x's on both sides, so I am going to choose to subtract 4x on both sides. And then I'm going to add 12 on both sides. So I get x equals negative 4 here. And then I'm going to go ahead and distribute this negative. Negative 4x, positive 16. Okay, and so I'm going to go ahead and add 4x on both sides. And that will give me 9x minus 12 equals 16. And I will add 12 to both sides. That will give me 28. And I'll divide both sides by 9. Okay. So these would be my two answers. X equals negative 4. X equals 28 over 9. All right, so that is it. If you have any questions, make sure you email me or text me or post it in the discussion